Text for today, earthquakes. Remember, you can also access this on your McGraw-Hill app through ClassLink page. You can listen to it. I've sent it out on your PowerPoint attachment too. And then, of course, I've made you a read aloud video. So let's look at our text for today, earthquakes. When I look at just this screen here, I can already pick up a lot of information just without even reading it. First of all, I know what the main idea is going to be. And I know that my main idea is going to be about earthquakes because it's got the main topic, your title, as being earthquakes. So I'm going to label this MI for main idea. Okay, and just by looking at the photograph here, I can tell that this is going to be an informational text because I see a real picture. I see a real picture of some, looks like some breaks in the crust of the earth. Okay, and so I know that this is probably going to be teaching me information about earthquakes. So everything I should read should be about earthquakes. Your essential question that you've been working on is how do people respond to natural disasters? Remember, a natural disaster is any phenomenon that occurs in nature that changes the shape or the layout of Earth in some way, okay? And then you've been talking about this week, how do people react? How do they respond? What do they do after a natural disaster occurs? And so another natural disaster that we're going to look at is an earthquake, okay? Now this right here is called a heading, okay? When you're reading informational text, this is your main idea. This is the main topic, okay? That's your title. This over here is called your heading. And headings are used to tell you or to break the information into smaller sections to let you know what each page or each section is going to be about. So yeah, we know that we're still going to be talking about earthquakes, but specifically in this section, we're going to be talking about a shifting planet. Shifting means to move. So we're going to be talking about how our planet moves. So let's read it and find out. We like to believe that the ground under our feet is solid and secure. People who have felt the ground shake know differently. They have lived through an earthquake. Earth's crust resembles a jigsaw puzzle more than a solid sphere. Like a puzzle, the crust is divided into different pieces that fit together. These pieces are called plates. Earth's plates float on top of a layer just below the crust called the upper mantle. The upper mantle is solid rock, but it behaves like a thick gel. Heat from deep inside the earth moves through the rock and causes it to slowly swirl and flow. So when we look at this page, and we know that we're talking about, everything's talking about how our planet moves and shifts. Think about, and we'll use this picture here, when I say we, people, we live on the crust. That's the layer of the earth that we live on. Okay, so the car, the people, the trees, our houses, things all sit on the crust of the earth. And it says that the crust is more like a puzzle than just a big solid sphere. Okay, and the reason why it looks like a puzzle, and most of you have probably put puzzle pieces and things together, because the crust is divided into different pieces. We have all different kinds of pieces of land, and these pieces fit together. And when they fit together and then there's no problems, then it's fine, okay? Nothing happens. But sometimes, and if you've ever put a puzzle together and you think you found the right piece, and you're just trying your best to make it fit there, and it just won't fit, but you keep trying to cram it in there to make it fit, then just like with an earthquake, if these plates sometimes just don't fit together just right, then something's going to happen, and then that's when we're going to get an earthquake. So these moving pieces of land are called plates, and they float on top of the mantle. The mantle on the earth is it's solid rock, but it's, in the center of the earth, of course, it's extremely hot. And so it floats around, kind of like it said, like a thick gel, okay? It's still solid, but it kind of moves a little bit, okay? So when the crust is sitting on top of this mantle and the mantle moves, it's going to cause the crust to, plates are constantly moving, okay? So let's continue reading to see what happens with these moving plates. Dr. Inés Cifuentes is a seismologist, someone who studies earthquakes. She likes to compare the movement of Earth's plates to boiling milk. When you boil milk, she says, you get that little surface layer of cream on top that moves and dances around. That's what's going on in the Earth, except that Earth's crust is much harder than the layer of cream. As the mantle boils, it pushes and pulls the plates above it. It's at the edges of these plates, Dr. Cifuentes explains, where we have most earthquakes. So let me pause for just a second. and ask you, according to what we just read, what does the text say a seismologist is? Correct. A seismologist is someone who studies earthquakes. And we're going to hear a lot more of this Dr. Cifuentes. And says she is a seismologist, so she is someone who studies earthquakes. And she said, think of it this way. You think about the plates on Earth. And here, go ahead and look at this picture down here, and you can see the outline of the plates. They're all different shapes. They're different sizes. You can tell that they do look like a puzzle, how they kind of fit together. But she said these plates, of course, are always moving. And think about if you've ever seen your mom cook or you've ever tried to make hot chocolate or something. When you milk really and it starts to boil, it creates this little layer of cream on top. And so the milk is really hot and the cream is up on top moving around, just like on the Earth. Really hot in the center of the Earth, and the plates and things are moving around on the top of the Earth. Okay? And so if you look at this picture here too, we have a caption that goes along with it. Captions, of course, are used to explain and tell you more information about a picture. It says the white lines on the map above show plates on Earth's surface. The red dots show where earthquakes have occurred. So if you look at this picture here, and I'll give you a second to think, where do most of the earthquakes occur? Well, according to this picture and what we read here, earthquakes occur at the edges of the plates. And if you look at every one of these. They are occurring at the edges of these plates. Now, here's one that did not, and sometimes it can happen, but most of the time, you're going to have it occur at the edges. Okay, so let's continue reading and see why most earthquakes occur at the edges of these plates. So this heading over here on this page is going to be Earth's largest quake, a first-hand account. Dr. Inés Cifuentes became a seismologist for a very good reason. She and her family lived through the largest recorded earthquake in history. This was the 1960 earthquake that struck Chile. As Dr. Cifuentes explains, in April 1960, my family moved to Santiago, Chile. Just a few weeks later, on May 21st, we were woken up by strong shaking. Then 33 hours later, a gigantic earthquake hit the southern part of Chile, and with it, an enormous tsunami. About a year later, we took a trip to the northern end of the earthquake zone, and that's where I saw that the land had actually been raised up a meter or so. I saw these huge changes, and that impressed me, that the Earth could actually do that. Later, as a graduate student, I wanted to know how big that earthquake was, how long it lasted, and whether it was preceded by a slow earthquake. I worked on this problem for 4 years. I was able to calculate that Earth's largest recorded earthquake had a magnitude of 9.5. I also confirmed that a slow precursor or forerunner had occurred 15 minutes before the main earthquake. I am very proud of this work. So, this seismologist that we were introduced to over on page 12 said that she became a seismologist because her family had lived through the strongest earthquake ever recorded. Okay, it struck in the country of Chile. It was in the year 1960, so this was several years ago. It said they had a little bit of a warning sign. They were woken up by strong shaking. And then 33 hours later, a gigantic earthquake hit Chile. And so living through that, she wanted to grow up to learn more about the earthquakes. And then she worked for several years, and she was actually able to figure out and calculate that it had a magnitude of 9.5, and that, yes, it did have a warning sign about 15 minutes before the main earthquake. So because my screen's shaking. Because she had lived through it, she grew up to want to learn more about it. Okay, let's continue reading. Whose fault? All right, so whose fault is it? Let's read about fault lines. Earth's plates crash together, spread apart, and slide against each other. Whenever they do this, they cause breaks in Earth's crust. Seismologists call these breaks faults. Usually, the blocks of rock on each side of a fault just sit there stuck together. But when enough pressure builds, the two sides of the fault can suddenly shift or slip. This sudden movement releases waves of energy. These waves travel through the earth. We feel them as earthquakes. Most faults do not slip and cause earthquakes. Around the globe, however, active faults cause hundreds of earthquakes every day. Most are too small for us to notice. Once in a while, Earth unleashes a whopper. And so these plates that we've been talking about, most of the time they're fine and they don't cause any major earthquakes. Well, anytime that these plates either crash together, slide past each other, or pull apart from each other, then that's what's going to cause a fault line, and that's what's going to cause an earthquake. Okay, so when these plates are acting nicely and they're not doing too much bumping or pulling apart from each other, then things are fine. But every now and then, if there's a sudden movement or a sudden bump together, then that's going to cause all of this waves of energy and stuff to just continue out across the land, and that's where we get an earthquake. Okay, let's talk about measuring earthquakes. Okay, how do they measure how strong an earthquake would be? So everything under this heading is going to tell you about how they measure them. Seismologists record earthquakes using machines called seismographs. These measure shaking or ground motion. After an earthquake, scientists read their seismographs. They use their readings to calculate the earthquake's size or magnitude. Magnitude scales are set up so that each whole number is 10 times larger than the number before it. A magnitude 7.0 earthquake, for instance, is 10 times larger than a magnitude 6.0. Truly giant earthquakes happen about once a year. These are quakes with a magnitude of 8.0 or greater. They occur only on very large faults and can cause severe destruction. Dr. Cifuentes explains, the only way you can get an earthquake like the 2011 Japan earthquake is where one of Earth's plates is sliding under another one. This is the only kind of place where you have a fault long enough and wide enough to release that kind of energy. Seismologists gave the 2011 Japan earthquake a 9.0 magnitude. It was the fourth largest earthquake ever recorded. They believe the earthquake occurred on a fault more than 150 miles, 250 kilometers long. It shook Japan for 3 to 5 minutes. It was so powerful that it altered the geography of the country. Surprisingly, it wasn't the shaking of the ground that did the most damage. A massive wave proved much more destructive. So, they use a magnitude scale. The higher the number, of course, the stronger the earthquake. The higher the number, the more severe, severe means something that's extremely bad. So the higher the number, the more damage that it's going to cause. The 2011 Japan earthquake, you can always go and research that more, because what was interesting about that one, if you look on down here, it says it was a 9.0, so a very strong earthquake, but it altered. Altered means it changed the geography of the country. It completely changed the shape of that country's land. And what happened was what was so unusual, like Dr. Cifuentes says, that the plates, that one plate slid up under another one, which doesn't happen very often. But when that plate slid up under it, it caused so much pressure. Of course, they had a big earthquake, but not only was it from the earthquake, but they also had a massive wave proved much more destructive. And a massive wave is called, and we read it a while ago, it's called a tsunami. And so, like, if you look at this picture here, like where this little earthquake happened out here in the ocean, when it happens in the ocean